Very good morning to all of you, my dear students. I hope you all are very fit and fine. Welcome to the next class. In this class, we will study the concept of temperature. Okay, as we know that in our universe or our locality, in our world, there are many things which are very hot and there are many things which are very cold. Okay, we live in between them. Okay, so we must need some physical quantity to measure what is hot and what is cool and how cold. Okay, so for this instance, for measuring this type of things, we have came up with a physical quantity which is called temperature. Okay, temperature is defined as hotness or coldness of anything. Okay, temperature is defined as hotness or coldness of anything. So temperature is defined as hotness or coldness. Okay, so in this class we will study what are temperature, different types of temperature, their units and their instruments to measure them, just like other physical quantities. Today we shall explore temperature. So are you all ready? Let's begin. So here in this picture, my dear students, you can see that a fox is there, which is struggling a lot with the cold snow and trying to find some heat. But here, this lady having a bonfire is quite satisfied. Okay, so these are at same place. There are two different temperatures. Just beside that bonfire is temperature below minus some degrees, because it is freezing, na, it is ice and it is frozen. So if the temperature will be more than 0 degrees, then it will become water, but it is still ice. That means it is less than 0 degrees, and inside that bonfire the temperature will be more than 100 degrees, because there is fire, and that fire is always more than 100 degrees. Okay, so this is the range, this is our the beauty of our planet, that we have varieties, we have variations, we have you know uh, diversity amongst everything. Okay, okay, so let us continue and see the introduction of temperature. So the first thing is that I'll put it here. First thing is that what we discussed right now, that we have a variety of things like snow, frozen snow which is here on the ground is very cold. Ice cubes which are there in our fridge is less colder. Our body is moderate in temperature, neither too hot nor too cold. Cars are little bit hot in the sun, or when they are running their engines are hot, and again the sun itself is very much hot. So we have a variety in the universe also, in the uh, planet, on the planet also, and in our life also. Okay, we have a variety of everything, and that is good thing, isn't it? Okay, so next thing is that temperature is the degree of hotness or coldness of a body. Something is how cold or how hot, that degree. And if something is hot or cold, and if hot, how hot, and if cold, how cold, the degree of hotness or coldness is measured with the help of temperature. Okay, one something interesting is that the hottest temperature ever recorded was in Death Valley, California. Okay, okay, and it was recorded as 56.7 degrees C. Imagine that. Imagine that temperature, 56. Okay, in our area, our locality, if the temperature becomes 35 degrees C, okay, or 37, 38 degrees C, we that is a news in our town, that oh my god, today what was the temperature, it was 38 degrees Celsius or 37 degrees Celsius. Imagine what will happen at 56.7 degrees Celsius. That was recorded in Death Valley, California on 10th July 1993. Okay, and one more thing, the coldest, the lowest air temperature ever measured by a weather station was minus 89 degrees Celsius. Minus 89, my dear students, water freezes at 0 degrees Celsius, and the lowest air temperature ever measured by a weather station was 18 minus 89 degrees Celsius, as recorded there at Russia's Vaskov station in July 1983. Okay, so here is one image of it. Okay, so Vaskov. Okay, Vaskov, Antarctica, minus 128 degrees Fahrenheit. Okay. Okay, so what is so this is the what we discussed, the variation. There are a lot of variation. Now we shall discuss units to measure temperature. Okay, so the SI unit of temperature is Kelvin, K, which is denoted by K, just like the SI unit of Celsius is not Celsius. The SI unit of other, we have other SI units of all the physical quantities. Similarly, temperature also have an SI unit, and that is Kelvin. Okay, and it is represented as K. Some other units are also there as these, like Celsius, Fahrenheit, and Kelvin. There are three units which we use to measure temperature. Now, in our schools or from the very beginning, we know that okay, there are three units, Kelvin, Celsius, Fahrenheit, but how to convert them was a hectic process. Okay, so I have researched and found out a video in which it is very well explained that how can we simply calculate uh, temperatures, units of temperatures, and convert them. If you want, this is out of syllabus, nothing will of this video will come in your book. If you want, you can fast forward this video 5 minutes, or if you want to know about how to convert, how can we simply convert these units without doing tough calculations and applying formulas, this video is for you.
We have heard of temperatures like 0 degrees Celsius, which is the freezing point of water, and 100 degrees Celsius, which is the boiling point of water. Though Celsius is a more common way to measure the temperature, Fahrenheit is also sometimes used as its unit of measure. 0 degrees Celsius is the equivalent of 32 degrees Fahrenheit. There is a particular way in which we can convert Celsius to Fahrenheit and vice versa. This is the formula to convert Celsius to Fahrenheit. We multiply the temperature in Celsius with 9/5 and add 32 to it. And modifying this formula, we get the conversion from Fahrenheit to Celsius, subtract 32 from the temperature in Fahrenheit, multiply it with 5, and divide the entire thing by 9. So how much time do you think you'll take to convert one to another? 12 degrees Celsius is how many degrees Fahrenheit? Or 23 degrees Fahrenheit is how many degrees Celsius? Look at it a bit practically. If somebody asks you this in real life, they are not expecting a perfect answer. What you need is an approximate value. Using these formulae will give you the perfect answer, but you'll take too long to arrive at it. So let's see a quicker way to arrive at an approximate answer. Let's say you want to convert Celsius to Fahrenheit. All we need to do is multiply the temperature in Celsius with 2 and add 30 to it. That will give us the answer in Fahrenheit. Say 10 degrees Celsius. We need to convert this into Fahrenheit. Multiply it with 2 and add 30. 20 plus 30 is 50 degrees. 10 degrees Celsius is approximately 50 degrees Fahrenheit. Multiply with 2 and add 30 to the product. 17 degrees Celsius. 17 times 2 is 34, and 34 plus 30 is 64. 17 degrees Celsius is approximately 64 degrees Fahrenheit. If we do the exact calculations using the formulae, we would have got 10 degrees Celsius as 50 degrees Fahrenheit. Yes, we were a bit fortunate here. And 17 degrees Celsius as 62.6 degrees Fahrenheit. Almost equal. The higher the temperature, the bigger will be the difference. Say 50 degrees Celsius. 100 plus 30 is 130 degrees Fahrenheit. The exact answer is 122, a difference of 8 degrees Fahrenheit. And converting 100 degrees Celsius to Fahrenheit, we get 230 degrees approximately, and the exact answer is 212 degrees Fahrenheit. So as the number increases, the difference or error in the answer also increases. Does this work for negative temperatures as well? Absolutely. Say minus 15 degrees Celsius. Minus 15 times 2 is minus 30, and minus 30 plus 30 equals 0. Minus 15 degrees Celsius is approximately 0 degrees Fahrenheit. The exact value comes out to be 5 degrees Fahrenheit. So to convert from Celsius to Fahrenheit, just multiply by 2 and add 30 to the product. And how do we quickly convert Fahrenheit to Celsius? Easy, we subtract 30 and then divide by 2. Take 100 degrees Fahrenheit for example. We subtract 30 and get 70, and 70 over 2 is equal to 35. 100 degrees Fahrenheit is approximately equal to 35 degrees Celsius. The exact answer, if you calculate, is 37.7778 degrees Celsius. The difference isn't much. What about 72 degrees Fahrenheit? Subtract 30 and get 42. 42 over 2 is 21. 72 degrees Fahrenheit is approximately equal to 21 degrees Celsius. Now let's try converting minus 40 degrees Fahrenheit to Celsius. Subtracting 30, we get minus 70, and dividing it by 2, we get minus 35 degrees Celsius approximately. The exact value in these two cases is 22.222 degrees Celsius and minus 40 degrees Celsius. A very small degree of error in each case. But what if you forget the ways of conversion? Remember, for the same temperature, Fahrenheit is always larger, so multiplying it with 2 and adding 30 will definitely give us a larger number. To convert from Celsius to Fahrenheit, we multiply and add. And as Celsius is a smaller number, we subtract 30 and divide by 2. One good way to remember this is that C comes before F, so C is smaller than F.
Wasn't that interesting? Enjoyed it? So this way we can calculate Celsius and Fahrenheit, the most commonly used two units, very easily. Okay, so let us continue. Okay, so now we shall see instruments used to measure temperature. These are the units very clearly we have discussed it. If you have any doubt, we will love to clear it. Okay, and in the Google Classroom. And now let's see some units, some instruments rather, instruments used to measure temperature. So first one, my dear students, is a clinical thermometer. This is very new. We all of us not commonly use it. What is it? The thermometer used by doctors. No, clinical we use. Okay, laboratory we not use commonly. This is the most commonly used thermometer. By saying thermometer, we normally understand this, that oh, okay, clinical thermometer. The thermometer used by doctors to measure a person's body temperature is called clinical thermometer, or doctor's thermometer we also call it. It is usually graduated from 35 degrees Celsius to 42 degrees Celsius, or 95 degrees Fahrenheit to 108 degrees Fahrenheit. Okay, so this is why it is between this, why it is graduated between these temperatures only, because the human body, the temperature of human body or other animals bodies range between this only. Okay, so that is why a clinical thermometer have only this much of range between the measuring temperatures. Let's have a look on a clinical thermometer. This is how a clinical thermometer looks. We all are very familiar with it in our homes, or whenever we get sick we used to go to doctor, and thermometers, most of us also have a thermometer at our home also. Okay, now we have a laboratory thermometer. A thermometer used to measure the room temperature or the temperature of solids and liquids is a laboratory. In a laboratory is called laboratory thermometer. This is not very commonly found and we don't use it very commonly, but yeah, it is very important in the laboratories. Okay, why? Because the stem of the laboratory thermometer has graduations usually marked in degrees from minus 100 degrees to plus 100 degrees. It may vary, some of them may have less range, but yeah, mostly it is marked. The stem means the stick, the white stick you are seeing here, na? Like in this image also, these are stems of thermometer, the portion of the glass portion, okay, except for that bulb which is in the front, that is called the stem. So it is marked, it is graduated from minus 100 degrees Celsius to plus 100 degrees Celsius. Like in these images, it is not clearly seen the marking, but yeah, it is different. They have a wider range of temperatures. Okay. Okay, now let us see this. This is the diagram of a thermometer. Okay, first one, the thinner part is a bulb in which mercury is present, and then there is a constriction. Okay, like a I will say like a narrow the tube, that the tube which is running from here and there has a constriction. That means the path is little bit pressed. Okay, so that some amount of mercury after pressure it goes there. Okay, that like this is normal and this is constricted and then again normal. Okay, so and then we have a capillary tube through which the mercury travels. Okay, and we have that stem on which markings are there. I would prefer to show you a thermometer on my own. Just give me a second. Okay, my dear students, we are back with the thermometer. This is Higgs thermometer, most commonly, uh, most famous company of thermometer, I guess. My mom says. Okay, so here we go. This is a thermometer. Today we shall also see how we can use a thermometer. Okay, so this is a thermometer. This one is the upper portion is the bulb, and this one is the stem on which, if you can see here, if I am able to show you, let me zoom it. Here are the markings. Okay, here are the markings, and if you will see, you will see one stainless steel type something is flashing na here in between. If you will see the thermometer, take the thermometer, and if you will see like this, and if you will rotate it simply like this, I am really able to show you what the temperature. See here, till here it is showing na, till here. Yes, and now you will see what measure it is. So it is 96, 97, 97 degrees. It is showing 97 degrees Fahrenheit till here. And how to, if you will take it, hold it tightly, otherwise it will slip and it will fall down and it will break broke. If you will simply do this, and then you will see, that the temperature has fallen down. See, till here it came, isn't it? And if you want to increase the temperature, then simply have a grip on the bulb and rub it tightly to increase the temperature. Yeah, see, again it is here, as you can see now. If you have a thermometer at your home, please have a look at the temperature range. Now see, can you identify where it is? Yes, right here. Okay, so this way you will keep it in the on the armpit, like this, on the armpit, and you, the patient to whom's temperature you, body temperature you want, and leave it like this for a minute or two, and then you will take it out from the sick patient's arm, and you will simply keep it towards the light, and you will simply rotate it like this, and you will be able to see the fever. You will be able to see what is the degree of, see here it is. Okay, so this was it, thermometer. Similarly, the same mechanism is also used in clinical thermometer. Only thing is that that one is larger and have a more larger or have compressed or thick bulb, more I mean designed such a way that it could show a wide range of. If you want to see the this portion, the constriction, I don't know I will be able to show you or not, but here if you will see, you will see a small note like something. Can you see this here? Small note like constriction. Yeah, so that is it. This is a thermometer. Okay, instruments used to measure temperature. So I hope I'm clear. uh, the only thing which you need to remember is the range of a clinical thermometer and a laboratory thermometer. This is the only difference between these two thermometers. Laboratory thermometer is laboratory thermometer generally ranges from minus 100 degrees Celsius to plus 100 degrees Celsius or simply 100 degrees Celsius, and clinical thermometer ranges from 35 degrees Celsius to 42 degrees Celsius or 95 to 108 Fahrenheit. In this, it is measured from 94 to 108 degrees Fahrenheit. Okay, and Celsius, it is measured from 35 to 34 and half to 42 degrees Celsius. 34 and half or 35 to 42 degrees Celsius. Okay, if I will be able to show you, I would have shown, but it is very small. The inscription is very small. So here in this image you can see from 34 or 35 to 42 and these things. So this is very clear, I guess. Now my dear students, because I'm a science teacher and my purpose of teaching science is to make you all smart with the instruments and technologies and science. Okay, use science. So we will not stop here. We will see the modern instruments used to measure temperature, which we really use nowadays, that are electronic thermometer. And I have also bought one to show you. See, this is an electronic thermometer, and how does it works we will see here. So it also have two types, laboratory and clinical. Okay, the same difference is here. Let's see the image. The same difference is here. This one is a clinical thermometer. This one, as you can see, the left one, right one, I guess on your screen, I guess this will come on right. Okay, the white one, okay, is a clinical thermometer. The same difference is here also, my dear students, the range of temperature. Laboratory thermometer will have more range from minus 100 till up to plus 100 it could be, but clinical thermometer will have a shorter range, the range of which human body temperature varies. Okay, okay. And how does we use it? How do we use it? First of all, if you will have a look, it will be switched off. First you will, here is a button, here is a button, we will press it, and then we will be able to see some, yeah, nothing is showing, I guess. Yeah, here can you see some 1.88 something written, and we will have to keep it in some place where we need to measure the temperature, and after a minute I will keep it in my armpit for you. Okay, and after a minute it will start beeping, and once it starts beeping you will have to take it out and simply see what is the temperature of that place. Okay, so this is clinical thermometer and laboratory thermometer. Okay, now we will see some interesting thing which is not given in the textbooks, but I thought it would be better if you will understand about it. There is one camera, my dear students, which is also called as night vision camera. Have you ever heard about it? In the movies generally they show this, that army paramilitary forces of USA are going somewhere and they are having a look in the forest, and the criminals, bad guys, are unable to see them, but they are having binoculars, night vision binoculars, and they are able to see the bad guys in the dark woods and sharply shoot them at the point. How do they do it? What is that thing? That is an infrared camera. Actually, all of the objects present around us emit some infrared, have some temperature, and anything which have temperature. Have you heard about infrared? That is a, how will I simply tell you? That is a type of, or you can say, color of light. Okay, you can say that just like there are blue, green, red now. So after red, the next color is infrared. Simply, if we will discuss about it. So infrared is a color. So what happens? Anything which is hot will emits anything which is hot emits some infrared. Okay, everything. Like I am hot, more than 0 degrees. So I will emit some infrared, and anything which is below 0 degree will not emit infrared. Okay, so how does that camera works? That camera has an receptor which receives infrared signals, I mean infrared lights. We can see now if something is red, shining red, and we will take out our smartphones and simply click a photo, then we will be able to see there, yeah, that is red, see here it is showing red. So similarly they have designed a camera which shows that infrared. They see there is infrared, here is it is infrared. Okay, and they are able to see that hot object. Okay, same technology is used, and we have came up with this infrared thermometer. Okay, how does it looks? It comes in a variety of colors because many of us likes color options in everything, so we also get a color options, a lot of color options here. This is an infrared camera, my dear students. Why I am telling you this? This is not in the syllabus, this is not in the books, but this is really used, being used in real life. Everywhere you, wherever you will go, you will see these type of thermometers. Simply putting on your head and telling that yeah, you are good to go, you are not good to go. How are they doing it? You must know this. Okay, because you are mature enough to understand these things. What is that? What are you putting on my head and simply confirming that I am healthy and I can go inside? Why? How? So this is how. What they are doing, they are actually measuring your body temperature. They simply pointed it, and one infrared receiver will receive the infrareds which is coming out of my head. Everything emits, everything which is more than 0 degree emits some infrared. So they will simply receive it, and they will check that okay, our school also have it. If our school reopens this year, you will be monitored every morning with this infrared thermometer. Okay, so 36.9 degree it is showing, like in other examples 36.8, 37.6, 38 point. So these are the other just an examples. So this how it is, this is how it works. Okay, infrared. And why and how someone can be so sure that if your temperature is not high, higher than normal, higher than average, then you are healthy, you are not COVID patient? Because my dear students, whenever we get a virus attack, our body fights with that virus. And while fighting, have you ever fought with someone, your siblings? You will notice that when you are fighting, your body becomes hot. Even if when you are angry, your body becomes hot, ready for damage, helps you to fight, increase in temperature. So whenever some virus attacks, we fight. All the cells together combine, hands join hands to hands and fight that virus. And while fighting, the temperature of the body rises. So if your temperature is more than normal, that means something is wrong, definitely wrong with you. Some virus have must have attacked, and something, some kind of fight is going inside your body. But if your temperature is normal, that means you are normal, no virus is attacking you. Okay, so this is the first level of screening of COVID-19 patients. This is infrared thermometer. We will have a look for better understanding how it works. See, this gentleman is holding that, and a laser is going out. Actually in real life you will not be able to see that laser because we are not able to see infrared lights with our naked eyes, so that will be not seen. But here in the representation you are able to see this. Okay, one thing I can show you right now. If you want to see infrared, have you ever seen a remote control, my dear students? And there is a light on the top of every remote control. Okay, but you must have imagined that why there is a light, what is the work of this light? Someone have told you that it gives out signals. Have you ever seen that signal? No, we are not able to see it with naked eyes, but our smartphone cameras are smarter than us. Some features are smarter than us, not smarter than us, but some features they can do better than us. excuse me. So today I will show you how does an infrared light looks. See closely. See, let me switch off these lights, and now you will see this. See, this is how an infrared light looks, my dear students. Slightly purple. You can do it with your own remote also. Any remote, take out a remote control, and take out your mobile phone. Just keep that in front of your camera, and you will simply see, will be able to see these lights. Isn't it interesting? So this is infrared. Okay. I hope you enjoyed today's class a lot, because I also enjoyed it a lot. And I guess my thermometer has died because of low battery. Thanks due to this class. I came to know it, and I will replace it tomorrow. So thank you very much for being with me till now. And if you have any doubts regarding all the concepts which we discussed today, please let me know in the comment section, and I will love to clear them all. Thank you very much.